Assalamualaikum warahmatullahi wabarakatuh and good evening. My name is Aiman bin Zaki, number metric 174872. Okay, today I'm going to make a video about an assignment for dynamic class. In this assignment, we have to take a question and do the solution for the question. Okay, today this is the question. I'm going to do the question part. Okay, the question is the 50 kilogram crate shown in figure 13. This one rests on a horizontal surface for which the coefficient of kinetic friction is mu k equals to 0.3. If the crate is subjected to a 400 Newton towing force, determine the velocity of crate in 3 seconds starting from rest. Okay, as you can see in this example, this is the crate has been subjected to a force of 400 Newton with an angle of 30 degrees. So the perimeter in this question is, the perimeter given is force 400 Newton, angle 30 degrees, and the coefficient of kinetic friction equals to 0.3. Okay, now in this question you have to find the velocity in 3 seconds starting from rest. That's all from me. Thank you.
Okay, so now I will explaining about the free body diagram for this problem. So here we have the crates and the mass of the crates is 50 kilogram, and then to solve the problems we need to change it into the Newton, and it has the Newton about 490.5 Newton. And then of course for every action we have the reaction according to the Newton's third law. So we have the reaction over here that acts upon of the weight of the crates, and then the crate is subjected to a 400 Newton towing. So we have the force that pull the crates over here is about 30 degree from the x-axis, and the force that pull the crates is about 400 Newton. And then of course the crates is not moving on the smooth surface, and we have the frictional force that acts to the left of the crates. So here is the frictional force that acts on the crates, that is F equals to 0.3 NC. And then for the last thing, we assume that the acceleration of the crates is at horizontally to the crates. So we can see that here the acceleration is going over here. So that's only in this free body diagram. We have two unknown only to be settled. That is, first is the NC, and the second one is the acceleration of the crate. So that's all.
Assalamualaikum and very good evening. My name is Muhamad Zulasyraf Bin Zi. My metric number is 178391. Okay, this is my part for show the calculation and also the formula being used in this our projects of dynamic. So now I will show you the calculation. So given the crate have a weight is 50 kilo and a force 400 Newton, and also the coefficient of kinetic friction is mu k 0.3, and I also show the FBD from the crates, and here weight, NC, kinetic friction, and the angle 30 and 400 Newton. So I will also show the y-axis and z-axis where acceleration assumed at the horizontally in the at axis. So the first of all we must find the weight. So the formula of weight is W equal to mg. So we put 50 kilo times 9.81, so we get the answer is 490.5 Newton. So next steps is solution is using the equation of motion. We can relate the acceleration to the force cause the motion. The create's velocity determined using the kinematic. So this we must find the velocity decrease in the 3 seconds starting from rest. So first of all we must find the equation of motion. So we get a fx equal to mas. So we put 400 cos 13 here, we put here, minus 0.3 nc equal to 50a, and then we find the y-axis, nc minus 590.9 plus 400 sine 30 equal to 0. So we solution this nc is equal to 219.5 Newton. So we find the fy first. So we take 400 cos 30 minus 0.3 nc equal to 50a. So with solution we get equal the acceleration is 5.185 meter per second square. Thank you.
Hi, my name is Ahmad Hilmi bin Muhammad Sharif, metric number 177967, and for my part, I will continue the solution to find the velocity. So, since we already get the acceleration is equal to 5.185 meter per second square, and we know that A is constant since our force direction P is also constant. To find V, we will use the velocity equation where V equal to V naught plus ACT, where the equation is velocity as a function of time. So we already know that the crate starting from rest, and we will get V naught equal to 0 and T at T equal to 3 seconds. Since the question 1, the velocity of the crate after 3 seconds from rest, we will input the equation with 0, there is V naught, plus AC, the acceleration equal to 5.185, and the T is 3 seconds. And do not forget about the unit. And lastly, the answer is 15.6 meter per second in the positive x direction.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad Hafiez Ramli and my metric number is 1825. So for this question, the 50 kilogram crate rests on a horizontal surface for which the coefficient of kinetic friction is 0.3. If the crate is subjected to a 400 Newton towing force, determine the velocity of the crate in 3 seconds starting from the rest. Okay, so the first step for the solution is we must draw the free body diagram. Okay, as we know, the weight of the crate is 50 kilogram. So weight transform the unit to the Newton. So we must times 9.81. So when we times 9.81, we get 490.5 Newton. Newton, right? Okay, then we got the W. Then we can solve. Okay. The frictional force is 0.3. As we know, frictional force is always opposite the direction of motion. So it must opposite direction. Okay, the degree is 30 degree, and the force of the crate is 400 Newton. So with all the information given, we can get the acceleration and velocity. Okay, first we resolve it into x and y component. Okay, for component x, F equal to ma. So the force they include in x component is 400 cos 30 degree minus 0.3 Newton. That is force F. And 50 is the mass of the crate, 50. And A is acceleration, unknown. We don't know the acceleration. Okay. Then there will be the first equation. The second equation, we must resolve the y component. The y component is much easier than the x component, because it does not include the frictional force, because frictional force is always act on x direction. So this is y direction. So we just include NC minus 490.5 plus 400 sine 30. That is F, total force. So M is 50, and Y acceleration in y direction. So in question we know that the acceleration is always on x direction. So in y direction there's always zero acceleration. So times 0, 50 times 0. So that's why we get 0. Okay, then we just solve it and we get the NC. NC we got 290.5 Newton. That's the second equation. Okay. Then we just include the second equation into first equation to find the A. Then we got the acceleration. This is 5.185 meters second squared. That's the acceleration. And C also we managed to get that. Okay, back to the question. Determine the velocity of the crate in 3 seconds starting from the rest. So we know that P is constant. So we chose the velocity equation. V equal to V0 plus acceleration times t. Starting from rest, V0 equal to 0. From rest is 0. Then based on the formula, we just insert the value obtained. So V equal to V0 plus acceleration plus time plus acceleration times time. So V0 starting time is 0 plus acceleration. What is our acceleration? We get from the first step, that is 5.185 meters second squared. So time is 3 seconds, because the question asks for 3 seconds starting from the rest. So 3 seconds. So solve it, we get a 15.6 meters squared. That's the velocity. of the crate in 3 seconds. First 3 seconds. Okay, I think that's all. Thank you.